Okay, nice. Okay, let's just start. I guess just to cut down on even more time, I'll just go straight to answering the questions. Yeah, sorry for this one, medyo late siya. Um, had to step in and teach this one. Yeah, okay. Sige. So just, I'll give you guys 10 seconds pause to view the problem, and then we just go straight into it. Okay. Oh, okay. Oh, shit. Okay. So una, show that your neutral axis is situated 125 mm below the top surface. So just take our, sorry, just take this, and then, okay. So we have to show that the neutral axis is 125 mm below the top surface. So, uh, essentially, and it's equal to the summation of a y over a. So basically just sum the areas. We can split this into simple shapes. We get the area of those, and then we divide it by the total area times the centroid. So let's just figure out where the centroids are. So let's just split it into the shape. Centroid is just here. So this is half of 150. Di na pala ganun matter along x kasi yeah, we're referring to beams naman. So just along y, this is uh since it's asking us to refer below the y-axis. So this is 150 plus 50 over 2, 175. This is 150, so just half of that, 75. Okay. Uh, so now let's just label this one in 2 for simplicity. For clarity, I mean. I just use a smaller pen for now. Okay. Oh, it's too small. Okay. Oh, oh no, no, no. Okay, sorry. A and then Y. So area of 1 is just 150 times 50, 7,500. Y position is 75. 2. Also 150 times 50. That's also 7,500 or 7,500, sorry. And then Y position is 175. So just remember we're referring this below the top surface because that's what the problem says. So, but just make sure to make it consistent. 15,000. So summing them together, you get 15,000 total area. Oh, so, and then get the products. So getting the products, you have 7,500 times 75, and then 7,500 times 175. Um, so that means, I'm just doing it sa calculus. Okay, so this gives us 562, 500. This gives us 1,000,000, 312,500. Also, just for the sake of units pala, this is all in mm. So nothing weird naman so far, but sometimes you will have conversions in the middle. So just to track na okay pa so far. Yeah. Okay. So then this will become wait, five, five, six. So 1,875. So you get this number and then divided by 15,000. Uh, so then you divide this by this, sorry, this by this, and then you get 125. So yeah, um, oh, sorry. So that's the first part. Uh, okay, second part. Draw the shear and moment diagram. So this is our load diagram. So essentially, mag-a-apply lang tayo dito ng concept where we increase by a power of 1 yung curve every time it goes from load to shear and shear to moment respectively. Okay, it's lined up nicely. Uh, just to make it easier to draw. Okay. Um, okay. So now, looking at this, so obviously, just to note, hindi pa siya naka-solve dito. Hindi pa siya naka-explicitly nakalagay. But don't forget there are reactions here. Let's try actually right now if there's a way to solve it. So these are both roller support. They act like roller supports, but so just I pin pala, they're pin supports. Same thing, all you need to know here is that wala siyang moment reaction. So finding RA, B. Um, so okay, let's do this. So checking along FY. Checking along FY, we get RA plus RB minus 3 times W, which is our unknown here. That's the first. That should all equal to 0. Moment about A should be equal to 0 also, because we're assuming that this is not like about to tip over, like kasi statics, diba? So then, what that means is that you have. So let's try to reduce this into a ano muna, singular point force. So 1.5, 2 plus 1 over 2. So meaning 1.5 to the left of this point, meaning you have, so this is 2 plus 1.5. So you have around here, point force. This is found about 3.5. Yeah, so that should be relatively straightforward now with a force of 3W. So going back, moment A, walang RA. RB is 4 minus 3W times 3.5 meters. Okay. B naman, moment at B, same thing, walang internal reaction. So, dito naman negative 4A, 4RA, minus 3W, dito naman 0.5 because it's 0.5 meters away from the pin support. Yeah. Okay. So ayan, that's basically our setup. Uh, from this, we have two equations. We have three equations actually and two unknowns. But we only need two. So therefore, we can easily derive the call that can easily derive the both the unknowns because we have more equations than unknowns, or an equal number of equations and unknowns. So solving that, RA plus RB equals 3W kasi i-refer mo siya, transpose mo siya. 4RB, 3 times 3.5. Okay. So this gives us RA is equal to 3H W, and then RB equals 21 over 8W. Sorry, omega pala yan. I guess just to note na this is quote unquote in like may dala tong meters na ano na because yeah, you used meters to get this, so technically my meters yan somewhere. This is just important for later. So I guess I just put something like this. That doesn't mean that the force is in meters. Just means na we have kasi W, di ba? From the start. This is technically yung units nito is Newton over meter. So, yeah, may meter tayo na unit na carried over. Okay, same thing here. So, moving on. And now we have that. Now we can write everything in terms of W, just makes our lives easier. So, start here. Just going left to right. So, una, my reaction force tayo from A, which is upwards. This is 3/8 omega. And then we have nothing up until the 4-meter mark, or the 2-meter mark. And then my uniform downward force tayo. Again, this is a since naka call that degree 0 na loading, meaning the curve of the shear diagram has to be -1, has to be 1, so it's sloping up or down. It's sloping down kasi this is negative, right? This is negative, so therefore this should be sloping down. And just to get where its final point is, so let's just get ito muna na area kasi may may point force dito. So we want to get this area. That's just 2 times omega, so that's -2 omega, meaning from positive 3/8 omega, 3 over 8 minus 2. So that's -13 over 8 omega. So we go all the way down here. Okay, this is not to scale, obviously. And then, may point force tayo dito na 21/8 omega. So 13, -13/8 plus 21/8, that gives us 8/8, which is 1. I'll just put that here. 1 omega. And then I have one remaining, which is this area, 1 meter times omega. So that's 1 omega, 1 times 1. So bababa siya ulit dito. And then we just draw a straight line connecting the point. Ayan. So then mag-close na siya dito. Flat line na to dito. So that's our shear diagram. Essentially, relatively straightforward pa naman. Let's move on to our bending diagram. So same thing here. It's about getting the area from the left to the right. One additional thing lang though is in bending diagrams, right? The points where the shear is 0 now matters. So we have to figure out ano yung x value nito, tong point na to. Okay, so let's figure this out real quick. So this entire length is, as given in the problem, 2 meters. This height is 3/8. And then, tama. The whole length is 2 meters pala, by the way. Not, let me just make it clear. So the whole segment is 2 meters. And then, what else? What other info do we have? This height is negative 13/8. Yeah, so the height is just 13/8. We know that these both add up to 2, so I'm just gonna arbitrarily set this one as x, and it follows therefore that this is 2 minus x. So then we can use similar triangles. So 13 over, so let's just, so x over, so that's the base, over 3/8, that's equal to 2 minus x over 13/8. Okay. So x 3/8 equals 2 minus x. (13/8). Solving for that, we get 0.375, or in fraction form, 3/8. Okay, so now we know the length. This is 3/8 plus 2. So 3/8 plus 2. So we know that this point is 19/8. Yeah, so now this is at x equal 19/8. So now we know this is x equals 19/8 meters. So yeah, we can now proceed. All right, so now what I want to do next is just build the bending diagram. So start tayo with this area. Is 3/8 times 2, so we get 3/4. This is a degree 0, so we expect that the new diagram, the bending is degree 2. So then this is 3/4 omega. And then we have a triangular part. So let's just do this part first. We expect na mag-flat line siya dito, right? Because that's v equals 0, which is a point where the moment diagram peaks. So in this case, let's just get, so the x, we know the distance is 3/2, 3/8. So 3/8 times 3/8, because that's the area. Specifically 3/8 omega. So 9/64. We add that to the 3/4 we currently have. Wait, sorry. We have to So 3/8 times 3/8 divided by 2 plus 3/4, we get 105 over 128. So now ano yung concavity? Look at the shear diagram. So at here, the slope is 3/8. At here, the slope is 0. Meaning dito, 0 yung slope mo. Dito, positive yung slope mo. So connecting those 2 points together, you get this. And this is 105 over 128 omega. Okay, so that's the first part. Next naman is yung pababa. We know that this is 2 minus, we know that the length is 2 minus 3/8. So that's 13/8. 13/8 times 13/8 over 2. That gives us negative 169 over 128. So that's the negative. And you add 105 over 128, 1/2. Negative 1/2, sorry, specifically. So meaning, mag-end up ka dito. Let's just say this point is negative 1/2 omega. Now, what you want to do is just figure out yung concavity niya ulit. So this is at 0, so it's flat ulit siya dito. And this is going to be negative 13/8, so that's where it's steepest, meaning the concavity continues pababa. Okay, and then you have a point, sorry, you don't. Then the next is this last part. Medyo not to scale na talaga siya. This is just 1 omega, this is 1, so you have 1 omega times 1 omega over 2, meaning 1/2 omega. Tama kasi dapat mag-i-increase talaga siya pabalik. Mag-close out siya. Here, this is 1 omega at this value and 0 here, meaning yung 0 mo is nandito, yung 1 omega mo, which is the positive slope, is nandito. So magaganito siya and should close it out. Because we're dealing with the second and third degree curves na and you can tell them apart. Let's just label second degree curves and that's that. Tapos na yan. So that's for the first part. That's for the first three. Yung pinapagawa is to draw the shear and moment diagram. So that's the second part. Done. Third part, calculate the maximum value of W in Newton over millimeters. So it's important na naglagay tayo ng units that the beam can carry considering the allowable shear stress to be 75 megapascals. Yeah. First trick question dito, it says the maximum value of omega, meaning ito yung susundin natin actually. Hindi tinanong yung allowable value of omega. So just a little trick they're trying to pull. Second trick is that this is in N over millimeters. We've been working with meter units throughout the whole time, which is why I wanted to emphasize this. So ito, pwede niyong isipin na all the values here right now are in millimeters squared, right? Kasi you multiplied it with like meter values with lengths. So we essentially have to multiply by, so kung may millimeter squared ka times, wait, yeah, kung may millimeter squared, kung may meter squared ka, sorry. Kasi all the units are in meters squared, like the hidden units inside. So this is in meters squared. To convert it into millimeters squared, you would have to multiply by 10 to the 3 squared, so 10 to the 6th. So let's just take note of that when we carry over the values na we're gonna substitute. So, okay, let's just go straight to the calculation. There's no. So see, so this is just a design problem when it comes to the shear stress. Stress is given by V over I Q over T. The reason why I like to separate them is because you maximize this in design problems. So specifically for Tmax, we want to get Vmax. And for shear, the direct for yeah for what you call that, for shear stress, it doesn't matter. We just get the absolute value. In this case, that's 13/8. So again, 13/8. So we're just getting the magnitude omega. Remember na may carried over units to the meter squared for multiplication later. The hell? Oh, what? Okay. Oh my god. Okay. Ri is given already at the neutral axis, which is 53,125 times 10 to the 3 millimeters raised to 4. And then our Q over T is now what we want to find. Our figure is not just our figure is has junctions, meaning we have to also consider what the potential value might be at the junction. So, yeah, kapag wala kang junction, then matik na neutral axis na. Pero if meron, then you have to consider junctions. It's a bit too large. Okay, dito. So now we want to find Q over T max. So let's take our first candidate, which is the neutral axis. We establish this to be around here. So this is your NA. And then the junction that we want to investigate. Okay, let's start with the neutral axis. So to get Q is just the area of either above or below the point times the distance of the centroid of the shaded area to the neutral axis. So that's this. The magnitude, sorry, the centroid of this is around here. Specifically, that is, okay, let's just keep referring above, from relative to the top for consistency, 75. Oh, wait. No. 125 to yung height niya, divide by 2. It's actually 62.5. Sorry. Okay, 62.5. So now, our Q can be quite straightforward to find because it's not a double figure, so one figure lang. This can be found by getting 125 millimeters. Shit. 125 millimeters times the area. I times the base times height to get the area. So that's we got the height. The base is 50, and so again, this is just A times Y. So then the distance to the neutral axis is 62.5. Well, both same naman sila, pero it's better to refer to it here. Okay. And then since we're getting the maximum Q over T, let's also just get our T. This is 50 millimeters. Conveniently cancels out. That's nice. 1.25 times 62.5. So this gives us a value of 7812.5 mm squared. So that's our neutral axis. Let's test our junction. Same thing here. It's quite convenient. Okay, whatever. It is more convenient. Same lang naman yan. Dapat above or below again. Yeah, tama. So this is 125, meaning the gap between here to here is 25 mm, because it's at y equals 125 below, and that the whole length is 150. So our Q this time is 150 yung base. Oh my god, mukha siya. Ito yung base niya. Yung height is 50 mm. And then yung distance is 25. Ay, distance of the centroid, guys. Meaning hindi siya 25 lang. Plus the centroid, 25. Plus 25, so 50. Over 50 millimeters. Oh, conveniently cancels ulit. Not sure if that always happens. I don't think so. So the Q here, Q over T na pala to. Kasi this is the, yeah, this is the thickness sa baba, right? Because it's just, oh, this one pala is not, good, sorry. The thickness of that one is not 50. The thickness here is 200. Pero you're also getting the distance to the centroid. So okay. Medyo double mistake. Somewhere here, yung centroid, 125. So the distance from 125 to 175, that's 50. So that's 50. That's 25 plus 25 plus, yeah, okay. Sige. Uh, wait, okay. Okay. Never mind. Sorry, guys. Tama na pala to. Pero we have to get the lower of the two thicknesses. So, dalawa kasi yung possible thickness. So, tama na yung 50. While the thickness of this is 200, we want to get the lower of the two thickness. Sorry, guys. This is 50 mm. Also, so tama na yung Q, 7,500 millimeters. So I guess just take note of that na even if you're getting like ito, technically that should yield the same value. The only difference is you're getting this point no, right? So you're getting the lower of the two thicknesses independent of whether or not you're getting above or below. Okay. Sorry about that. So now we can go to the main part. So yung pinapahanap is 150 pascals, megapascals. So let me just then convert that for a quick shorthand para we can check dimensional consistency. Newtons over millimeter squared. 13 over 8 omega. May dala yung units, meter squared, from the previous calculations. And then this is 7,812.5 millimeter squared over 53,125, 10 to the third millimeters to the fourth. So let's just check for dimensional consistency. Maging 2 yan. See, may meters tayo, may millimeters sa baba. So we have to do meter squared here. Do millimeter squared here para mag-cancel. Then we apply the appropriate, so that's just 10 to the 6th. And then this will all equal to, let me just get my calc, 13/8 times 7812.5. So solving for omega, we get, okay, we get 0.627, 6276, mag-around 628 newtons. Okay, sorry. Yeah, wait, parang may sobra. 1.5. This is in, I double checking lang. This is, okay. Something's off. Okay, so then this is in kilonewtons. Kasi this is in kilonewtons pala. Per millimeter squared. Right, so we canceled that out. Oh shit, sorry. Okay, my bad. Okay, so then this will be equal to 627, kasi if you don't round it, magiging 627.692 newtons per mm squared. Yeah, so that's the maximum that your top section can carry. Okay, that's isa lang pala dapat to. Yeah. Yeah, kasi your Q is only 1 unit. Okay, so correction lang dito. Okay, moving on. Now, the next thing pinapahanap sa atin is maximum value of omega in Newton over millimeter such that the beam can carry all these considerations. So, sabay na natin yung D and E kasi they're both actual force problems. So the maximum tension is 250 megapascals. The maximum compression is 150 megapascals. So, all right, let's go straight into it. So yung pinapahanap naman dito is recall for actual stress, actual bending stress. This is equal to MO. This is equal to My over I, where Y is the, not naman the centroid, but the position, absolute position. So we have two scenarios here basically. If we use, so that's why we have to take two scenarios, because if we use the highest positive moment, i.e. gaganito siya, the centroid is around here, diba? 125. The top part will be compression. The bottom part will be in tension. If we use the negative, so getting the internal axis here, this will be in tension, this will be in compression. So we essentially have to get the maximum cases We have to essentially get we've got four answers, and then we'll pick two as the most relevant ones for us, depending on what they are. So let's first start with a positive moment. This will cause compression at the top. So our highest maximum moment is 105 over 128 omega. Ito yung my squared kasi twice na ginamit yung length and meters to multiply. So this is 105 over 128 omega meter squared. Plugging that in, so then we multiply this by, so my, so y is just the position relative. So since this is compression at the top, the distance from the centroid to the top is 125. Not that diagram. Here, 125. And then the distance to the bottom, let's note na rin is 75 para di na tayo babalik-balik. Okay, and then let's just do the conversion factor here. 10 to the 6th mm over, okay, 10 to the 6th mm over mm squared over meter squared. Okay, tapos what that gets us is divide this over I, so 53,125 times 10 to the 3 millimeter squared, millimeters raised to the fourth. So canceling all this out, you'll end up with one lang to. So you'll end up with, you'll have to equate this to the maximum. So we have compression at the top. Our maximum compression is 150 megapascals, which is equal to 150 Newton over millimeter squared. Sobra na naman. Okay, tama lang pala. Yep. Okay. To the fourth. mm squared, meter squared. So then the answer you'll get here is omega is equal to 77.714 newtons over millimeters. Hmm. Okay. Hindi pa kasi ito na-cancel. So, yun pa lang yung na-cancel so far. Meters. Tapos you have, okay. Kasi this is, so magiging ano to, 3. And then, okay. Yep. So then, yeah, that's how you'll end up with that. Okay. Up next. So you'll have tension at the bottom. So that means na just plugging in the same 105 over 128 omega. So that's in my meter squared then dala. Minus 75 was we're referring to yung sa ilalim ng ano, neutral axis. And then same conversion, 10 raised to 6 millimeter squared over meter squared. All over 53.125 times 10 to the 3 mm to the fourth meter squared, meter squared, meter squared, meter squared. And then this is meters to the fourth. Magiging the one na lang yan. Yeah. So that makes okay. And then this is equal to negative 250 kasi it's in compression, it's in tension. Okay. Over mm². So therefore, solving this, our omega is equal to 215.87 Newton over mm. Okay, just to explain yung dimensional consistency dito. So the units you basically have left are W over mm. That's equal to N over mm². Essentially what happened here is that for this to be equal to this, W therefore has to be in Newton over mm to match the one on the right. That's essentially what happened here. Like in yung units ni omega. So yeah. So these are our two values so far. So moving on to the other case. So my other case tayo dito, which is on kung if m is negative or if the moment is negative. So yung mangyayari dito is essentially you have tension at the top and compression at the bottom. Okay, and what that means is that we take naman the most negative of the two, so that's negative 1 over 2 omega. And then multiply that, yeah, same case here. So we take the top first, so meaning 125 mm. Let's not forget na may mm squared too. And then we have a conversion ulit of 10 to the 6th meter squared. Ay. Oh my god. Wait. Over meter squared. Oh god. This is mm squared. Ay, meter squared din, sorry. Meter squared. So then divide this all over the I, which is the same exact one times 10 to the 3 mm. And then same thing, magka-cancel siya dito ng, so this is mm squared. So mag-cancel siya ng raised to the fourth. Cancel 1 plus 2, 3. So matitirhan ka ng isa dito. This is equal to, since the top is in tension, 250. Okay, so now, that's essentially the equation. And then solving for omega, we get 212.5 Newton over millimeters. So that's the third one. Comparing lang. So we have two cases for tension now. We now have to decide which is more overruling. So napansin natin na there this one is lower than the other one, meaning if we subject a loading of 212.5 or 215.87 on on the beam, yung mangyayari pala is magkakaroon ka ng sobrang taas na moment such that it will exceed the 250 in the negative case. So hindi siya pwedeng lagyan ng loading na ganyan, meaning ito yung mas limiting factor, smaller load. Generally, for design problems, smaller load, higher diameter, higher thickness, yun yung nag-govern. So for the last case, compression siya at the bottom, copy everything. So same thing here, 75 pababa, 75 din dito. Oh. Times 10 to the 6 mm² over meter². Meter², meter². So you'll have that, and then over the moment of inertia ulit, 53,125 times 10 to the 3 millimeters raised to 4. 1, 2, 3, 4. So magka-cancel yan lahat. This is equal to 150. Oh shit. 150 Newton over millimeter squared. Yeah, same thing ulit. And then just plug that in. You get omega equals 212.5 newtons over millimeters. So, same thing, pipili tayo which one is more limiting. As you can see, mas mababa yung 77.714. Meaning for compression, it is the bottom loading that we are more, the moment loading at that point, which we are more concerned about. So meaning, mas malaking limiting factor yung yung sa bottom. And then, so that's for D and E. So the answer for D, which concerns tension, is 212.5 Newton over millimeter. For compression naman, 77.714 Newton over millimeter. The last one is just to provide a conclusion on the permissible value of omega in Newton over millimeter, considering everything. We just get the lowest of all the values we found. So the first value we found is 627.692 Newton over millimeter squared. Dapat ano to? Over millimeter lang. Yeah. So just to make the canceling appropriate here. Yeah. We just take the lowest one, which is this one. So this one is the one that governs. Okay. Sige. So that's for the first problem. Moving on to problems 2 and 3. Crop muna. This problem 2. So this is a DIM problem. Pinapasolve lang yung, well, these things. So again, I'll take a pause here, take a screenshot of the questions. Okay. So this is for problem 2. So this is DIM, Macaulay functions, and the like. So let's first start with the moment function of the beam. It gives us actually technically mas strategic dito ang from the left, but we from the right going to the left, but we have been instructed to use k as the origin muna for the first problem. So, alright. Sige, let's just break this problem down. First concern we have right off the bat is that the when we were given a list of shorthands, di ba? Na parang pag ito yung itsura, automatic na ganyan siya. The triangle that was given for Macaulay functions looks like this. Increasing siya. This is decreasing. So this is a problem already. So we have to find a way to replicate this without uh to find like a different type of loading without that still acts the same way. So what I'm gonna do is and then okay. So the first thing that I'm gonna do is just make a loading here that acts the same way. This is also 20 kilonewton over meter. Right, but Macaulay functions, they have to extend until the very end. So now we carve this out. So what I want is something that makes the loading here zero. Kasi zero dito, di ba? So gusto ko rin na zero dito. So yung gagawin ko is I'm gonna make an upward force that's also it's also triangular that has the same slope. Okay, with drawing this is an upward force, an upward loading. So I want it to have 20 kilonewton over meter, 20 kilonewton here. So replicating that is meaning we have to find yung ano dito. So we can easily do that using similar triangles. This is 3, this is 3, this is 20. X. So x over 6 is equal to 20 over 3. Solving that, you get 40. So this is 40 kilonewton 40 kilonewton over meter. And then since may extra ka ulit dito na you need to cancel this chunk here, may extra kang upward force, you have to deal with that also. So you parang tinapakan mo yung kakatapak mo lang by adding another triangular force here that's downward to cancel this one. This will have, so this is 20, right? So meaning to match the 40 here, you have to add another 20 here. Yeah. So yeah, this is your appropriate Macaulay function. Now we'll have to find the expression for this. So what I like to do is sort them in power para lang maalala ko. So una is the two triangles, and then we'll do the uniform loads, and then we'll do the ano pa? We'll do the reactions. So just bringing those back here. Syempre may RK ka dito. Tsaka MK. And then you also had loading here na 15 kilonewtons. Should have just kept it, no? Okay. And then here you have 3 kilonewton load. So adding that all together, so So una, yung degree 3 mo. So the slope here is just 40 over 3. 40 over 6, which is 20 over 3. So you have 20 over 3 over 6. Um, this is x to the 3. And then just to make it look clean, just lump them spherical level, x raised to 3. So these are all the triangle ones. Then adding the uniform downward one is negative. 3 over 2 x raised to 2. And then I'll add the point force, which is positive 15. This happens sa my x equals 3. So x minus 3 dito raised to 1. Then I have rk x raised to 1 also. And then I have mk. The external moment is positive, therefore the internal moment is negative. Negative mk x. So yeah, this is the moment function. I guess just to solve for rk and mk as well, this is just equilibrium equations. So if you apply equilibrium equations, you will get mk, you get rk equals 18 kilonewtons pataas, and mk equals the 3 kilonewton meters upward. So wrong assumption tayo dito. So magiging negative siya. Ay, correct assumption. So magiging negative. So it's negative the same. Yeah, okay. So I guess let's just substitute that for full correctness. Nakuha lang to from the equilibrium equations. For the 0. Okay. So tedious. Compare this to the second part, which is just the from right to left naman, which is what the second subitem is. You'll realize it's easier. So let's just demonstrate. So from right to left, una is, let's get the degree 3. We're facing in the right direction now, so this is okay to do agad. 20 over 3 over 6. Negative pababa siya. X minus 3 raised to 3 minus, the next thing is the point force, which is negative 3. X raised to 1. And then plus 15. X minus 3 raised to 1. Yes, we still have reaction forces here, but because they are at the very end, they do not affect the Macaulay function. Kasi if you think about it, magkakaroon ka ng x minus 6. The greatest possible value of x in this case is 6. So any number smaller than that, you neglect the Macaulay function when it has negative numbers. Pag positive naman, or if it's exactly 6, edi mag-0 lang siya. So wala siyang effect sa final answer natin. Yeah, so that's for, so essentially this is your function. So I guess I just wanted to show the importance of choosing the right reference point. So now we can find the maximum y, which is what the third subitem is for maximum deflection. So we want to find the maximum deflection. But first, let's first find the place of the, let's first find the function for maximum deflection in the first place. No? So in this case, let's integrate this once. We get the the slope function. So bear with me. So this is now, okay, just to simplify things now. 20 over like 20 over 18. I don't want to lump in my arithmetic practice into Fermi. So minus 3 over 2 x is 2 plus 15 over 2. Okay, so that's our slope function plus C1. Uh, let's see. We can find a way to define C1 already. Looking at our function, looking at our equation here. At x equals 6, theta is 0. Why? Because this is a fixed support, meaning it restricts both deflection and angle. So this is here causes y equals 0, theta equals 0. So then at x equals 6, theta is equal to 0. So that's already my EI na to. Therefore, this is 0. This becomes negative 20. Negative 20. Let me just simplify it further. Negative 5 over 18. Uh, this is now 3 raised to 4. Negative minus 3 over 2. This is now 6 raised to 2 plus 15 over 2. This is now 3 raised to 2 plus C1 equals 0. Solving for this, like on your calculator, you'll get C1 is equal to 9. So then, you can proceed now. Wala na tayong unknowns. Let's proceed to finding the deflection function. This is equal to negative 1 over 18. Just for purpose. 5 over 18 times 5. X minus 3 raised to 3. I raised to 5 na. So integrating ulit. 3 over 2 times 3. X raised to 3. 15 over 2 times 3. X minus 3 raised to 3 plus 9x plus C2. Applying our second boundary condition here at x equals 6, y equals 0. Okay. So this is now negative 1. Right? Now this is negative 1 over 18. So just simplifying it further. This is now 3 raised to 5 minus 1 half. 3 raised to 3. 6 raised to 3 plus 5 over 2. 3 raised to 3 plus 9, 6 plus C2. You will get that C2 is equal to 0. Kasi equate this to 0, C2 is also equal to 0. And therefore, wala siya. So, your final deflection equation is just given by ELy of x is equal to negative 118. X minus 3 is to 5 minus 1 half x raised to 3 plus 5 over 2 x minus 3 cubed plus 9x plus 0. So just include that. So that's our final deflection equation. Now let's try to deduce where our points of interest are. We were given as a hint na you have 3. Okay. Now you have 3. So maximum deflection, there are 3 potential points. So this is a cantilevered beam with load up until free end. kung sa AM pa, this is a case 1. What matters the most to us is that means that in a cantilevered beam with no support on the other side, always a candidate for max deflection yung pinaka-right. So that's the first part. So that's the first candidate. So yeah, from kasi nag-right to left tayo. So x equals 0. Second is I guess, the point na mag-change yung applicable na Macaulay functions. Note na hanggang at the point 3. So kung less than 3 ka, hindi to kasama. So nag-change yung Macaulay function mo. Beyond 3, sorry, wait. Beyond 3, so pag less than or equal to 3, hindi siya kasama. Pag greater than, okay. Pag greater than 3, then these are included. So this gives us a clue na potentially doon natin mahanap yung malaking difference. So x could be greater than 0 but less than or equal to 3. Or x is greater than 3, less than 6. So those are our 3 candidates. And we'll have different functions for each. So that remember, at the point of maximum deflection, the angle is instantaneously 0. So meaning, if you want to find the point of maximum deflection, we just have to find the point where the angle is 0. So this brings us back to our found na slope equation. Right? But we solved C1 again, so you can just put it as 9. So, looking at this, let's first consider the scenario where x equals 0. When x equals 0, our slope has no way of becoming 9. So automatic ruled out na to. Because if you plug in 0 at all of them, hindi mo mapapalabas na mag-0 yung slope. So it's not a point of contention anymore. For 0 to less than so x greater than 0 but less than or equal to 3, you want to consider the case where this is we want to consider what happens to these Macaulay functions, right? Kasi if it's always going to be less than or equal to 3, then they will always have values of 0. So essentially, you're only working with these values, with these equations. This is equal to 0. So solving for that, this is where it gets a bit iffy sa calc. You want to do something, wait, sige, pakita ko naman. You want to do something, like you want to do something related to, oh my god, wait. You want to do something to influence where it starts searching. Kasi there's a problem where the way the calculator looks for a solution is it basically brute forces everything. Pero malaking influence saan ka nagsa-start. This might happen pa lang sa big so pero let's just sa other case, pero let's just start here. X squared plus equal to 0. Solving for this, you get 2.449. So not a problem. Pero may cases kasi where let's say I can influence where yung starting point x niya. So let's say I put negative 99. So it will start searching and it will give me a negative value because this is a quadratic equation, right? So meaning it has two solutions talaga, sometimes positive, sometimes negative. The reason why I'm saying this is because lalo na pag raised to the 5, raised to the 4, you also have like something from algebra, right? Na the highest power dictates the number of solutions. So sometimes you have to manipulate yung starting x mo by manually typing it. So in this case, type ko lang, let's say, I'll type a positive number. So alam nating 2 yung sagot, pero let's say I have no idea. So I'll put 10 para alam kong yung first niya na matatamaan na solution is positive. Ayan, changes what X shows up. So yeah, this is an important tip. Wait, I'll keep the camera on because this will be relevant in the next one. So going back here, uh, so now let's look at, so this for the case 0 less than x less than or equal to 3. Let's look for the case 3 x greater than x less than or equal to 6. So we now have this equation. Let me just I'll take some time to plug it in. 20. No, simplify na to eh. Iba pala. Okay, whatever. 20 times 18 times 4 x minus 3 raised to 4. The reason why we select pala which equations to include and not include, even though like Macaulay functions, di ba? Technically, they include naman talaga zeros. Wala kasing Macaulay function sa calc. So sometimes, so we have to basically manually prune out expressions that should result in 0. Yeah. Yeah. That's nice. This is where this trick comes in, right? Kasi, okay, let's start. Imagine if I put 0 here. The default is 0 talaga. It will start solving. It will give me 2.6. But remember, our case is x is between 3 and 9. So this is one of the solutions you'll get because this is a to the fourth power. So you have 4 distinct solutions. So I don't want the calc to pull that solution up. So what I'm gonna do is, let's say I start at 3. Para yung pinakamalapit sa 3 yung tatamaan niya. Still gives me that answer. Okay, let's try 4. Para somewhere deep inside the range, makukuha niya. Okay, still gives me that. Let's keep trying. Let's try 5. Inside the range pa naman, so this is not a problem. Ayan. Now it gives me a number we can work with. X equals 5.613 meters. These are all meters, guys. So yeah, let's just keep going. Just to demonstrate. Kung mag-x equals 6 tayo, x equals 6 is also a solution. So actually, we uncovered 3 of the 4 solutions to this. But obviously, we only need this one that we found, right? Kasi if we keep going, baka matamaan natin yung other solution na actually, or I don't know. Okay, mukhang 6 na nga. So ayan. We ran into 3 potential solutions, but only one of which is valid. Obviously, bakit pala hindi pwede yung 6? Kasi alam natin na at the fixed support, y equals 0 yan. So no point looking for it. But yeah. Suggestion ko is intervals of 1. Just check your calculator in those intervals. Okay. Ba't ganun? Weird. Okay, I hope it's still recording. Let me check lang. God, if this was not recording, I might actually pass out. Okay, thankfully it's recording. I see it. Alright. Sige. Determine the maximum deflection of the beam. We found it. Ay, hindi pa. We found the candidates. So, 2 candidates. Sabi there should be 3. Pero we found the candidate points, but we again ruled out agad x equals 0 because we found out na hindi siya at all magre-return ng negative slope. Pero Okay, we still include it just for the sake of testing. Kunyari, pwede. No, kasi it's the oh shit. Okay, conceptually pala. Pwede siya technically because it's the free end. Pero sige. Anyway, let's just plug it in. When x equals 0, so this is now our comparison. X equals 0, makukuha natin na ry equals 0. So meaning, yeah, hindi nga siya yung point. And yung free end is not the point of lowest deflection. This makes sense kasi may upward ka dito tapos may downward ka dito. So medyo awkward talaga siya. E times 1 yx. Ikato naman. Let's test the second one. Plugging in x equals 0. Just to save time. I'm plugging in x equals 2.449. When you plug this in, you will get the value of 14.696697. May maraming variables pa yun. Hindi siya malinis. Dot, 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 dot. And then, at x equals 5.613, you get y equals 0.067 dot, 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 dot over ei. So this is your value. This is our lowest deflection of y. So, sige, just to finish the equation in finality. May e and I ba? Wala. Wala siyang given e and I. So ito na yung final answer natin. Since wala siyang given e and I. So that's the maximum deflection of the beam. So that's for number 2. Oh, di pa pala 2 hours. Okay. Technically, dapat max 2 hours lang kasi. I was concerned na hindi tayo matapos. Pero okay. I guess I did skip a lot of the solving, the manual solving. Okay, let's go. Last item. Okay. Alright. Ayan, ayan, ayan. Nice. Nice. Consistent. Kuha naman. Alright. Let's get this over with. An I section, blah, 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 blah. Moment of neutral. Moment of inertia at neutral. Okay, so this is an AMM problem. So, again, pag AMM problem, this is where my relationships na yung tangent and all that stuff. So I guess since I don't really explain it well, let's just go straight into it, no? So the first thing we want to do is to draw the M over EI diagram. In general, it's also the best thing to do at the start. Pero let me just complete first the FBD. So alam nating may reaction tayo dito at A. We have a moment at A. Let's just use the positive convention, yung smiling convention. So that's internally positive yan, pero externally negative yan. Yeah, external negative, internal positive. Such is the convention with, ano nga, diba? What you call that? Moments and like yung internal versus external. Anyway, important point is sa FBD, sa equilibrium negative yan, pero sa positive yan sa sa internal. And then you have reaction force of B here. And then, yeah, okay. I guess also just for later, we can convert this as a point load. 3 times 4, 12 over 2, 6 kn. It's kn lang pala, sorry. Kn. The distance here is just 1/3 of 4, which is 4/3 meters. Okay, so now let's draw the M over EI. Sorry, M over EI diagram. Eh, okay. So then, going off that, uh, para lang kasi magamit ko. Hindi ko na need mag-drawing. Okay, there we go. So ayan, A is our reference point dictated by the problem. Or it's also just more convenient. Anyway. So right now, later down the line, it also asks us to solve for the reaction and deflection at the pin B and the point C. Meaning, di talaga masasolve yung RA, RB by design of the problem. So technically, the first step here, if you're solving this for real, is to check the equilibrium equations. In this case, is skip natin, okay? Because we know na it's not possible. But technically, in an exam, you would still want to try first. But yeah, going off that, una, convert natin yung point moment na 8. Pag point moment naman talaga lahat ng moments technically, but ayan, height of 8 kn. And then the triangle, i-convert ay the reaction of A, ko-convert natin yan. Wait, sorry. Okay, the triangle of RP, i-convert natin yan. RA wala because it's at the point, it's at the, yeah, basta nandyan siya. Ayan, so mag-terminate siya dito. So yun, the magnitude is P times L. So we have 4 RB in meter. May dala yung meters na unit because you're multiplying by 4 meters. And then yung triangular, convert natin siya dito. This is a degree 3 because plus 2. So yung 1 degree naging 3 degree. Yung moment na 0 degree naging na negative 2 degree naging 0 degree. Yung 1 degree na RB naging na yung negative 1 RB naging positive 1. Okay. So this is 3. So omega L squared. Okay. Omega L squared over 6. So omega is 3 kn over m. L squared is 4 times 4, 16. So 3, 4 squared over 6. Dimensional consistency wise, kn over m times m. So we have kn which makes sense. We are summing or we are drawing moment diagram. So moment talaga dapat yan, kn. Sorry guys. Bit short of breath. Okay. So continuing on, this is our moment diagram as it is. No need to get the centroids and the stuff muna because mag-change yan depending on where you put the reference point. So then, draw the deflection curve for beam ABC, incorporate the necessary reference tangents and identities to answer parts B and C. So, for context, B and C asks us for the reaction and the deflection, but let's just, use our fundamentals here. So, una, first observation, let's base it off the tangent, the supports, kasi the supports give us information. So off the bat, we know that the displacement about A is 0. We also know the displacement about B is 0. Baliktad. Okay, so then, because of that, we also know that the angle at A, the instantaneous angle at A is 0. B, we don't know because it's not a fixed reaction, it's a pin reaction. So it allows tilting. So di siya kasama. From this information, we therefore know zero displacement, zero tangent, zero angle. The tangent line of A is actually just here. Diretso lang siya. It's a straight line. So this is our tangent A, meaning whatever yung A, gagawan mo ng T of anything with respect to A, it will just be equal to the displacement. So the implication here is that TA with respect to B just equal to, TB with respect to A is just equal to the deflection of B, which is 0. Okay. The next thing is sa deflection of C naman, TC with respect to A is just the displacement of C. Assuming the C is upward. Yeah. So what else? What else can we derive? I think, well, technically, if we really max it out, the angle of C is also equal to the over the length, which is 2. But I doubt we need this. Let's just start with the simplest one first, which is that the tangent of tangent of B, tangential moment of P with respect to A is equal to delta B equal to 0. Yeah. So given that yun yung information na makuha natin, let's actually draw the let's draw the deflection curve. So magsa-start tayo dito. This is 0 here. So we suspect because there's a downward force here. Magsa-slope down yan dito. And then it will come back at the pin, mag-0 yan. And I have a feeling it'll stay like this. Stay at the top. So yun yung projected. Again, pwede ito mag-iba, lalo na at the free end. Pwede namang you think magaganito siya. Or you could also think magaganito siya. Or even magaganito. Usually does not matter. Well, it kind of does, but it's not like there's no way to get it agad at the first try. So you have to really just solve for it and use a bit of intuition sa start, and then you change it once you solve for the values. Anyway, the important part muna here is that we found this relationship. This is what we will use. So, solve ko na lang sa baba. This is equal to 0. So what is T something over something? This is just, recall that this is just the area from A to B. And then the distance of the reference centroid for each figure with respect to B. So, given lahat ng value ng shapes mo, ano yung distance ng centroid niya to B? So, let me just bring this brown. Hindi nasama yung figure. Pahabol ko na lang. So, then, yan. Hindi siya aligned. Yan. Okay. So then, let's get TBA. So this is just base time times, I guess you could call it a fraction kasi na parang area coefficient kasi pag shapes, 'di ba? Nagmo-multiply ka by a fraction. This is the fraction given 1 over 1 plus n, where n is the degree of the curve. And then distance to the centroid. The distance here is given by n plus 1 over n plus 2, where n is the degree of the curve. This is measured from the vertex. For example, kung triangle. Kung right triangle, dito ka magsa-start. And so this is a degree 1 curve. 1 plus 1 over 1 plus 2. 2 over 3. 2 over 3 from this side, not the tall side, the tip, the vertex. Okay. So applying this to our uh, figure, we get, so the base is for, wait, I need to first refer, make sure we're on the same page. Alin yung ginagawa ko muna. So ayan, I'll just draw it. This is the itong pababa, and then wow. Uh, okay, wait. So then this is the triangle. Wait, sorry. Triangle, and then this is the rectangular area. So base is 4, height is 3 over 4, 3 times 4 squared over 6. 8. Okay, so that's the area, and then we have to multiply that by a fraction pa. This is a 1 over third degree curve to. So magiging 4. This is negative 8, by the way. So then our distance is given by, kasi nandito yun, di ba? Nandito yung centroid niya. Tama na it's referred to B. So B, the vertex is already at B. So that's not a problem for us. It's just the length. The distance is 4. Actually, I can just, para lang to make it even more, is the distance coefficient, area coefficient. So the distance is 4. And then the coefficient here is n plus 1 over n plus 2. So this is n plus 1. So magiging 3/4. Okay. So yeah, we're getting the distance from A. So magiging ganyan siya. Wait, 4/5 pala to, sorry. Kasi plus 1 plus 2. Okay, so then you multiply that all together. So times, 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 times. Or let's do it for everything. Base here is 4. Actually, all of them are base 4. Kasi ito lang yung kinukuha mo na area. Height for the triangle, this is 4RB. Yung height dito is 8. Yung area is 2/3 dito. Ay, sorry, not 2/3. 1/3. And then here is 1. Sorry, not 2/3. Not 1/3. 1/2. Kasi degree 1 plus 1. And then the distance is 4. And then because you're multiplying with respect to the centroid, ito yung centroid niya is 2/3 away. 2/3 times 4. Tapos ito naman for 1/2 kasi right down the middle siya. So 1/2. Para medyo mag-autopilot na yung pag-solve niya. Totaling these together, this is negative 128 over 5, 64 RB over 3, and 64. Okay. So you get the relationship from solving that. RB is equal to negative 9/5 kilonewton. Yeah, from solving that. So meaning mali yung initial assumption natin na pataas siya. Actually, pababa siya, which leads to 9/5 kn pababa. Okay. So that's our first answer. Nahanap natin yung RB. So that's for sub-item B. For sub-item C, determine the deflection of point C of the beam. Okay, so now, essentially, we repeat the same procedure. Okay, let's look at what we derived for point C. We were able to find out the point C is just equal to TCA. So we just repeat the procedure, but this time we know na iba na yung centroidal distance. This is also why I prefer to use tabular form. You just essentially import the information. Okay. So now we're solving for T with C. C with respect to A. So the distance this time to C is 6 for all. It's sorry. Yeah, tama. Kasi yung starting point nila is sa dulo. But then you're only getting okay, iba na dito kasi they don't span the whole amount. The whole thing, right? Hanggang 4 lang kasi sila. So now the way to get the distance from the centroid is a bit more mechanical. Or a bit more like you need to think a bit more. So yung sa dito, we know that the centroid is somewhere is 4/5. 4/5 along the length, right? So somewhere here. So we get 4/5 of 4, which we got to be 3.2. 3.2 is the distance from here to here, plus 2. So 3.2 plus 2 na tayo dito. Same thing here. It's a triangle. The length is 4. That is the centroid is found 2/3 from the vertex. So 8/3 plus 2 is 14/3. So just 4 uniformity 8/3 plus 2. And then dito, yung square naman is still spans the whole 6 meters. So it's the distance from 6. So it's just from halfway. So half of 6 is just 3. So ayan. Yeah. Sorry, a bit short breath. Okay. Makuha mong sagot dito from multiplying. So again, multiply the whole thing here muna. 41.6. Negative 41.6. 112 over 3 RB. And then 144. Adding all these together, you will get that. So since RB already has a value, diba? Just plug in. Still plug in negative 9 over 5 because that was kasi the entire solution right now rests on the assumption that RB is positive. So still plug in the negative version of the answer we found. You will get that delta C is equal to 35.2 over EI. Now, what are the units here? just so we know we're on the same page. So just recall what you did. So the base here is 4. This is in meters. The height here is mixed. The height here is in kilonewton meters. Right? Kasi this is a moment diagram. Yeah, make it okay. And then the area is like just coefficient lang siya. And the distance is in meters, and then the distance coefficient is also just in meters. So overall, we have a value in kilonewton meter cubed over EI. Our EI, as given, I believe, let me just double check. Yes, 21 times 10 to the 6th millimeter raised to 4th. And then our E is 200 gigapascals or 200K N over mm. So let's just write that down. So our E is sorry guys, 3 our E is 200 kilonewton over millimeter squared. And then our I is 21 times 10 to the 6 millimeters raised to 4. Yan. So magiging 2 ito. And then meter cube, millimeter cube, 10 raised to 9. Cancel, 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 cancel. Matitira is mag-cancel din to. Maging, so our delta C is in millimeters, which makes sense. Multiplying this final value, we get 8.381 mm. That's our final answer. So ayan, that's it. We're good. Okay. Under 2 hours. It's 1 a.m. I guess, sorry ulit on our end, tagal nito na upload. Couldn't find any tutors and yeah, I had 135 on Friday, last Friday, so could only record this now. Yeah. So again, really sorry for the delay. I hope this is still somewhat useful to the current batch taking. If not, this is the next batch na lang. Sorry. But yeah, hope this is still useful. I'll end the meeting here now.